Welcome back once again to another edition of your Adrenal Fix, where we teach exhausted and burnt out adults the truth about their health so that they can get their energy back quickly. And again, what another pleasure that I have here today with Dr. Bob Miller. This is our third edition, but each time we do it, there is so much more information to go over. And that's why I reached out to him again. But Bob is a traditional naturopath specializing in the field of genetic specific nutrition. And he's earned his naturopathic degree from Trinity School of Natural Health. He opened his Tree of Life and has served naturopathic traditional approaches for 27 years. And for the past several years, he's been engaged exclusively with the functional nutritional genetic variants and related research. Bob, I know I could go on, but we want to give the listeners some incredible value today. So thank you so much for your time.
Oh, always an honor to be here, and so much fun to work with people like you who understand this and see the value of it and want to pass it on to their viewers. So we're going to have some fun today.
Excellent. Yes, I appreciate that. So I will be quite honest, and I haven't been on every single one of your webinars, but what I do is, because you have an archive, I'll really go down those archives and really go in sort of a binge, if you will. So I've been on a binge recently, and I got to reach out to Bob because there's so much more that we know. And I think it's probably just best for you to take over the steering wheel and tell us what you've been learning with environmental factors that overlap with genetic susceptibilities that create these perfect storms of people that are getting sicker and sicker and sicker, and seeing more and more people that have very little answers for them. And maybe just take it away from there, Bob.
Okay, sounds like a plan. I'm going to do a screen share here, and let's see, there we go. You seeing the screen okay?
Yep, we're seeing the screen.
Okay, the two things we want to talk about today is RANTES and Ferroptosis, and these may be terms that some of your listeners may have never even heard of before. And we're going to be trying to explain what they are, how we get there, and then, of course, what we can do for it. And of course, I was mentioning, this is educational, informational only. We're not telling people how to diagnose or treat any disease. So, as I often say, this is the 3D chess game played underwater. Because a lot of times people are looking for, oh, what's the SNP, what's the gene, and then what do I do for it? And I'm learning over time that it's much more complex than that. There are a couple of SNPs in genetics that might be related to disease, but many of the things we're seeing today are just, as you mentioned, tired adrenals, worn out because they're making so much mast cells and histamine. And I believe these are two pathways that will create that, the production of something called RANTES and Ferroptosis. But as you mentioned, this is more than just genetics, it's environmental factors. There's an old saying of genetics loads the gun, environment pulls the trigger. And we're being exposed to so many new environmental factors. You'll get a kick out of this. One of my jokes is when I talk to people, I'll say, I was born in 1954, and that means I was born on a different planet than we are today.
Right.
When I was born, there was no such thing as high fructose corn syrup. We didn't give the animals growth hormones. We didn't genetically modify the foods. We didn't have all the Wi-Fi and cell phones. Our waters weren't polluted with plastics. We didn't have all the agricultural chemicals. We are just living in a soup of chemicals that nobody's ever done any long-term studies as to how they impact us. And when you look at how people are getting sicker, autism used to be 1 out of 1,000. Now it's 1 out of 44 or 45. When I was young, we used to call it adult onset diabetes. Now children are getting it. Autoimmune disease is going through the roof. Something is happening. Our genetics haven't changed. They're the same as they were 100 years ago. But the environment has changed drastically. And unfortunately, some people have genetic predispositions that they can't handle that as well. That's why you'll see two people living in a house, and one person is terribly impacted by the mold, and the other one says, this is all in your head because I don't feel a thing. And when they don't feel anything, they don't know that it's real, but it really is. And the environmental factors will affect one person more than another. And that's what we're going to talk about here today, Dr. Rosen, how the environmental factors are impacting those with some less than optimal genetic detoxification. Now, one of the first things we want to talk about is RANTES, and I would imagine this is a term a lot of people have never heard. It has an interesting name, regulated upon activation, normal T cells expressed and secreted. That's quite the phrase. But it's a powerful pro-inflammatory mediator of the chemotatic cytokine-chemokine family. And as it says here, it regulates the mobilization and survival of immune inflammatory cells from the bloodstream into tissues and other areas of injury and infection. The RANTES is associated with several detrimental effects: arteriosclerosis, liver disease, viral infections, and anything that interferes or slows down this RANTES is associated with improved outcomes. So here's how it's created: platelets, macrophages, epithelial cells, T lymphocytes, and it stimulates histamine secretion by mast cells. Now, Dr. Rosen, I'm sure you're seeing so many people with high levels of histamine coming into your office on a regular basis. Am I correct on that?
Correct. Yes, absolutely.
And it regulates T cells, macrophages, eosinophils, and basophils to the sites of inflammation. Now, I'm going to go through these rather quickly. I'm not going to read all the slides, but just to give some ideas of some of the conditions that the scientists are believing are related to RANTES. It's related to hepatic injury. That's your liver, promotes fibrosis by modulating the hepatic inflammation, so it can damage the liver. It's associated with autism spectrum disorder. So the hypothesis is that altered chemokine levels are involved with autism spectrum disorder. It's related to just inflammation. RANTES plays a fundamental role in histamine and serotonin generation and cell function in mast cells. Now, you have a sophisticated audience here who listens to you about the adrenals, and we'll get into this a little bit later, but as we all know, the adrenals need to make the cortisol that deals with the histamine. So anything that creates more histamine is going to stress the adrenals. In a study of eczema, RANTES and its receptors were shown to play potentially important roles in the infiltration, the ongoing chronic inflammation of the atopic eczema. Also reflects the severity of the disease. It controls the recruitment of leukocytes within the vascular wall, so it may have a relationship to arteriosclerosis. Inflammatory bowel disease. When they looked at the colonic tissue with patients such as Crohn's disease, there was significant redundancy in the generation of the signals in chronic inflammation from RANTES. Viral lung disease. So this was made quite well known by a physician who was studying COVID, and he found that RANTES was often very high, Dr. Patterson. And a study of 10 terminally ill critical COVID-19 patients, profound elevation of interleukin-6, that's that cytokine storm, and RANTES. The infection of respiratory epithelial cells equals an upregulation of that RANTES secretion. So there does seem to be a relationship between serious COVID and high levels of RANTES. And we'll actually very soon be going through the pathway maps and shows how that works. Diagnosis of prostate cancer was significantly associated with RANTES. And this study says our results and previously published findings on genes associated with innate immunity support the hypothesis that polymorphisms in pro-inflammatory genes may be important in prostate cancer development. So those are some of the things that can cause it. Now, don't be too intimidated by this chart. We're going to take you through step by step and show you what's happening. Let me grab the drawing tool here, and we will do a little bit of drawing. All right, I want to bring your attention to TNFA, tumor necrosis factor alpha. One of the things I like to say about this enzyme is that this is our friend unless it isn't. And what I mean by that, when we are faced with a pathogen of any kind that we need to kill, or even a cancer cell, tumor necrosis factor comes to the rescue. It stimulates something called NF-kappa B, which is inflammatory. Then it stimulates the NOx enzyme, NADPH oxidase. And you know, Dr. Rosen, I've been talking about NOx for years, and I'll just do a little explanation of that. NADPH oxidase is a fascinating enzyme. It is part of our immune system. It's there to come to the rescue to create mast cells and histamine when there's some bad guy in the body that we need to eradicate. Animal studies show if you knock this guy out, short period of time, the animal dies of infection, can't survive. But there are now so many environmental factors that are overstimulating NOx. And this is why we're seeing so much autoimmune disease. Now, let me back up here. You'll notice that mycotoxins, virus, Clostridia, Lyme disease, lipopolysaccharides, all will stimulate this TNFA. So if we're in chronic mycotoxin exposure, and there's debate on this, but Dr. Dietrich Klinghardt has hypothesized that Wi-Fi and cell phones is making mycotoxins stronger. And just for me in my own health coaching, so many of the individuals who are struggling, we find out they're living in mold and they have mycotoxins. Are you finding the same thing?
Yeah, absolutely. And to your point too, exactly the EMFs that they have the genetic weaknesses on create that perfect storm even further.
Absolutely. Now, people that are born in England, Ireland, sometimes Germany and Ashkenazi Jewish, many times have genetics that they absorb more iron. And you and I were just talking before the call that I need to add more to this. There's other genes related to this, but anytime you have extra iron, that will also stimulate TNFA, and we'll get a little bit more into that when we talk about ferroptosis. Now, the body is very amazing in that we also have mechanisms to slow this all down. There's an enzyme called SIRT1 that inhibits NF-kappa B and NOx, holds it back. So what an amazing intelligence there is in the body, Dr. Rosen, that this SIRT1 will say, I think you're getting a little carried away here. Let's just hold this back a little bit. Let's not get too carried away with inflammation. There is one SNP, one RS number, that is a genetic mutation that can downregulate SIRT1. But we're going to look back someday and say, oops, if you remember earlier, I said, I was born on a different planet when there was no high fructose corn syrup. We're going to look back on high fructose corn syrup and say, what were we thinking? Because it downregulates SIRT1. So no wonder we might be seeing so many issues today. And unfortunately, if you look at the foods that have high fructose corn syrup, it's pretty amazing. It only came about in the mid-70s, and the use of it has just increased dramatically. So high fructose corn syrup isn't good for anyone, but particularly if you have that one SIRT1 mutation where this is weak, you really need to avoid high fructose corn syrup. Now, there is another enzyme called heme oxygenase, HO1 and HO2. And it makes something called biliverdin and bilirubin. And people might be saying, well, bilirubin, isn't that why when babies are born sometimes they're yellow and they're put under a lamp? And bilirubin, if that goes too high, isn't that an indication of liver disease? Absolutely. But interestingly, a small amount of bilirubin, this blew me away, Dr. Rosen, when I saw this research. It inhibits tumor necrosis factor, inhibits NF-kappa B, inhibits NOx, and inhibits IL-6 that we didn't talk about yet, inhibits all of those. Now, you can have genetic mutations on heme oxygenase 1. There's also an enzyme called NRF2, NRF2, that stimulates heme oxygenase. You can have mutations here. The KEAP1 enzyme, this gets a little complicated. It inhibits NRF2, but it's kind of like a valve that senses when there's inflammation, and what it does, it releases NRF2. But you can have genetic mutations that NRF2 is upregulated. Now, interestingly, there's an enzyme called IL-10 that supports NRF2, but if you're exposed to a mycotoxin called citrinin, that citrinin can inhibit interleukin-10. So there's some mycotoxins that will stimulate inflammation, some mycotoxins that will even fight against your body to stop the inflammation. Then this whole thing needs something called heme, and there are 8 steps that we go through to make that heme. And we can have genetic mutations along the way here that will impede that. And then also, there's growing concern that Roundup glyphosate may inhibit glycine. It's debated. Some people say it does, some people say it doesn't. It inhibits the glycine which is needed for this process to work. Often when this is not working well, we get what's called hangry, where we'll get agitated, fearful, worried, and then we have something to eat, particularly a carbohydrate, and we feel better. And then this is succinyl's COA from the Krebs cycle. So if there's anything impacting mitochondrial function, or we don't have enough glycine, or we have glyphosate, or we have genetic mutations along here, we don't make enough heme. And then finally, there's a very fascinating enzyme called POR that donates something called NADPH to the heme oxygenase enzymes for them to do their work. Talk about a 3D chess game here, Dr. Rosen. There's an enzyme called FAD, which is dependent upon riboflavin. You can have genetic mutations in your riboflavin. You can have genetic mutations on POR. G6PD is a genetic mutation that often occurs in Southern Italians, Native Americans, Africans, many people from South America, where you don't make enough NADPH. And yet, to even further complicate it, it's controlled by NRF2 and KEAP1. So you can see how NRF2 plays a role in giving the body what it needs, plus controlling it. Now, we spent about maybe 90 seconds on that. If somebody really finds this fascinating, if you go on YouTube and type Carnahan, C-A-R-N-A-H-A-N, for Dr. Joe Carnahan, heme, Dr. Carnahan and I spend about an hour and a half just on this pathway here, pulling up all the peer-reviewed studies on what bilirubin does. Just blew me away when I learned about it, because I just thought of bilirubin as a bad thing. So what I'm saying here now is that when we get these environmental factors made worse by people with genetic mutations, and if I didn't mention, you can actually have genetic mutations on TNFA that makes it trigger happy, overactive. You might have some iron. You're eating a lot of high fructose corn syrup. You're being exposed to a lot of glyphosate. You've got mutations here. You are not able to hold back that inflammation. Then we get mast cells. And I'm sure everybody's now heard of mast cell activation syndrome. What percentage of the people you see, Dr. Rosen, do you think you see with mast cell activation?
Yeah, I mean, I would go as far as say 100, right?
Mm.
Because by the time they come to you and I, they have already exhausted a lot of their health challenges, and at some level, whether they have the gene SNPs or not, which they'll have some form of combination of the perfect storm of those environmental challenges, because we live in this world that was different than the one you were born in. Ultimately, I'd say probably every single one of them. Would you go as far as saying that too, Bob?
Yeah, I would say 85-90% of the folks that I see have mast cell activation. In other words, and if somebody doesn't know what that is, mast cells, again, they're our friend unless they aren't, meaning that they're there to kill pathogens. They're like the police or the military. We wouldn't live without them, but when they become overactivated, they start attacking the body. There's also genes called the KIT genes that can be mutated that are upregulation as well. Then we make histamine. And I'm sure probably a third of the people listening to this, at some time or another in their life, they have trouble with histamine. Well, if you're overproducing it, that's one thing, but there's also enzymes called ABP1 that make an enzyme called dynamine oxidase that degrades it. There's something called histamine N-methyltransferase that takes histamine, turns it into a form that I don't have listed here, that then has to be cleared by MAOA and MAOB, interestingly controlled by SIRT1, and then the aldehydes are the last step. So talking about the adrenals, the adrenal glands are very much involved in trying to deal with all this histamine through cortisol. We'll show that in a little more detail later. So your adrenals are going to get worn out if this is constantly a problem. Now, the next thing is the histamine stimulates an enzyme called INOS, inducible nitric oxide synthase. So let's talk about nitric oxide a little bit. People confuse this with nitrous oxide. That's what the dentist uses. Nitric oxide, if you Google nitric oxide Nobel Prize, you'll see 3 scientists in 1998 won Nobel Prizes for their work on nitric oxide as it relates to cardiovascular. Nitric oxide dilates the blood vessels, plus does a whole bunch of other things. So the NOS3 enzyme is what makes the nitric oxide that helps with circulation. NOS2 is somewhat related to your immune system, that when we're exposed to virus, bacteria, pathogens, parasites, this guy kicks in, makes a lot of nitric oxide to kill. Is that a good thing? Yeah, unless it's overactive. You'll hear me say this many times. So this extra histamine can stimulate this. There are 2 SNPs in NOS2 that actually make it overactive. Okay. And you'll notice up here it says Carnahan reaction. We actually named this after Dr. Joe Carnahan, who actually has some upregulations of her NOS enzymes. So if you're intrigued with this, again, just go on YouTube, Carnahan, and then INOS, I-N-O-S, and again, about an hour and a half on this. And that's just touching the surface. But what happens is there's a substance called BH4 tetrahydrobiopterin that's needed to make nitric oxide. Now, we don't have it on this chart, but there are genetic mutations that can cause you to make less of this. After BH4 does its job of donating, it turns into BH2 and needs to be recycled. Well, if it's not recycled or overused, we run out of BH4. BH2 is the only thing that's available. NOS keeps running, and rather than making nitric oxide, we make a free radical called superoxide. And I'm sure people have maybe heard the term Raynaud's, where people's hands and feet are so cold that they sometimes turn white or purple. That is related to not enough of the eNOS. iNOS suppresses eNOS. So in other words, when the body's got an invader to fight, it says, circulation, you got to take a back seat, we got to kill somebody. Again, we need that for protection, but when it's overactive, we have a problem. Then to add insult to injury, the superoxide combines with nitric oxide to make something called peroxynitrite, which is very damaging, very inflammatory. And if that's not bad enough, it further inhibits BH4. And we're on one merry-go-round here, Dr. Rosen, that just creates a problem. How much Raynaud's do you see in your practice?
I don't know. It's probably 50%. It's part of the symptomatology of cold everywhere. Lack of blood flow, brain fog. Are you correlating it with all sort of vascular decrease of blood flow, Bob?
Sure, absolutely. Yeah, these people also oftentimes get spider veins and varicose veins. Now, NOS2 stimulates or activates your platelets, and this makes your platelets sticky. Well, what happens when that happens? You're more prone to strokes and clots, which of course right now we're seeing a tremendous increase in. Then here we go, we stimulate RANTES. That's what we started talking about, RANTES. Now it doesn't end there. RANTES comes over here and stimulates mast cells, that stimulates more histamine, that stimulates RANTES, and we've got one merry-go-round going on here, just a feedback loop that just keeps going. And that's why some people are like, I don't know what's wrong. It just seems like keep getting worse and worse. Now, again, the body's pretty amazing. We all know the benefits of fish oils, and many people take fish oils and they're helpful. And I'm sure you'll see some people, they take fish oils and it's like, oh, it made me worse. Why? Okay. There's enzymes called FADs, fatty acid desaturases, that actually have to take those fats and put them into a form that we can use. And I'm sure if anyone's ever looked at a bottle of fish oils, they see EPA and DHA is the one that's the most inflammatory. There's a mutation here that can occur on ELOVL2 that this last step doesn't occur. But look at the cofactor. We need NADPH for these guys to work. And I don't know if I pointed this out, but the NOx enzyme uses NADPH to make inflammation. So NADPH is a fascinating molecule. It is used to help the fats be useful. It helps recycle your glutathione. It does many good things in the body. It's needed, if you look down here, it's one of the factors needed for nitric oxide. But the NOx enzyme also uses it to make inflammation. So let me say that again. NADPH can be used by some enzymes to be anti-inflammatory, but they can use by the NOx enzyme to make inflammation. That's the only molecule I'm aware of that can play a dual role: reduce inflammation or make inflammation. Well, if this guy's running all the time, you don't have enough here to help deal with your fats. You take fish oils and you feel worse. So that's why Bob Miller hypothesis, and that's just it, that overstimulation of NOx is the key thing that's occurring. And I'm going to show you how that actually occurs in ferroptosis. So I don't know if you ever heard of, if our listeners ever heard of like SPM actives. They are fish oils that are processed down to the point where they get these protectins and resolvins. And then that helps with this activation of the platelets. So now I'm going to go over another direction here. Any comments, questions so far on what we...
Yeah, I mean, I personally have, I think 8 or maybe 13 homozygous FDASs and so forth. Are you seeing that be very common too, Bob?
Extremely. And what's interesting, we have, for those of us who do this work, we're many times the last person that we see. I mean, people who, like for myself as a traditional naturopath, we're not the first place. I often get referrals from physicians around the world of, I don't know what to do anymore. See if Bob gives any insight. One of the most common things we see is mutations in the FADS enzymes, because you just cannot make the protectins and resolvins to calm it down. So when I see this, I tell people I have some friends for life for you. And that would be things like pantethine, choline, digestive enzymes that help break down fats. You can't fix your genetics. I should have mentioned this at the beginning. At the moment, the sperm and the egg that went together 9 months before you were born, your genetic pattern was made. When you leave this earth, it's going to be identical. So if you inherit some of these mutations, you can't fix it, but you can compensate for it. So these people oftentimes need to take DHA or protectins and resolvins or some things that help them break down the fats, but also we got to calm down NOx. Now, what happens is when this TNFA gets upregulated, either by genetic mutations, environmental toxins, lack of the HMOX not being able to hold it back, extra iron, there's an enzyme called PLA2. Now, this little diagram up here, or this little line rather, is the membrane of your cells. And there's something called arachidonic acid that is stored in the cells and plays good roles. It's not all bad. Arachidonic acid isn't all bad. But when it's yanked out of the cell membrane, it can go down multiple pathways. It can go down through COX2 and make inflammation. It can go down through COX1 and make something called thromboxane that can make your blood clotty. It can go down 12 locks, and we're going to talk about that next. So I'm just going to hold that thought. Or it can go down 5 locks and make what are called leukotrienes that can be very inflammatory. Leukotrienes are associated with hearing loss, heart palpitations, arrhythmias, and beginnings of memory loss. So we won't have time to get into that today, but either 5 locks, 12 locks, COX1 or COX2. There's an interesting urine test called urine inflammation that measures the thromboxane A2. And probably in most of the people we talk to in our health coaching, we have them do a little finger prick test called a mega quant that measures the arachidonic acid, the EPA, and the DHA, and then looks at the ratios. So look who calms down PLA2, corticosteroids from the adrenal glands.
Bob, can I ask a question? Sorry I know I won't remember because every time you say something so insightful, I come up with another question. So I hope you don't mind I'm interrupting. As far as the inflammation test that tests the thromboxane, and then you're doing the omega quant, when you've mentioned that you'll see pathway like used together, can you tell us about the utility of those two tests when certain values are low on one area and high on the other, how it directs your approach to helping with those patients?
Yeah, very, very good question. What's interesting is, as I said, thromboxane, makes the blood thick. And actually, this test is sometimes used to see if aspirin is being effective in helping the clotting. But and this is again, Bob Miller clinical observation only. Okay. But sometimes we'll see high arachidonic acid and high thromboxane. Sometimes we'll see high arachidonic acid and low thromboxane. What I've been hypothesizing, and it's just a theory, that when this is high and this isn't, it's not going down this pathway and is likely going down one of the others. And just from a clinical observation standpoint, that seems to be correct. So the two go hand in hand. This is called an inflammation test, and some people are freaked out. It's like, well, I'm beyond perfectly normal. What's wrong? Nothing. I believe that it's going down other pathways. And there are mutations in the 12 locks that I'm going to get to next that really creates what's called this ferroptosis. So here's your adrenal fatigue. Your adrenals are just beating the band as hard as they can to make the corticosteroids to calm this down. So what we have to do for this, there's various nutrients that we won't get into today, but there's various nutrients. One example is something called citicoline. There's also resveratrol that calm this down, but you also have to get out of the mold. And I can't emphasize enough how I believe mycotoxins is a huge factor for many individuals. Great Plains has a test on mycotoxins, real time. Dr. Andrew Campbell has a test. There's lots of ways to check for your mycotoxins. Then as we make more histamine, as we said, that stimulates the RANTES, the mast cells, and here we have yet another feedback loop that just feeds on itself. So what we want to go now, Dr. Rosen, is we want to move towards the next pathway, because I believe I covered everything here. So I'm now going to go to something called ferroptosis. Oxidative damage, that means the cells are being destroyed, to the cell membrane leading to cell death, related to iron, ion accumulation, and lipid, that's your fats, peroxidation, and they're the important markers of oxidative damage. It's iron-dependent, non-apoptotic form of cell death that is distinct from apoptosis, pyroptosis, and necrosis. Now, here's the cliff notes on what happens. And then I'll show you some of the things it's associated with. Then we'll take a deep dive. Look who's here, the NOx enzyme. Let me get my drawing tool here again. The NOx enzyme. And what it does, it takes oxygen. We spoke about this earlier, NADPH. That's why I call it the NADPH steel. Makes superoxide. Then an enzyme called superoxide dismutase makes hydrogen peroxide. Then iron combines in what's called the Fenton reaction. We'll get into that a little bit more. Make what are called hydroxyl radicals. Now, remember I said that ALOX, there's one particular ALOX 12 that brings your fats down, and it'll combine with this hydroxyl radical to make what's called a phospholipid hydroperoxide, which damages the membranes. And I was introduced to this by Dr. Harold Landis, one of the folks who uses our software and also is on the webinars. Brilliant gentleman dedicated to the wellness of humanity. And he introduced me to ferroptosis. And he kept saying to me, Bob, you got to look at this. And I kept saying, well, yeah, I'm looking at a lot of stuff. And I finally said, how about if you do a webinar on this? And he did. And I'm like, oh my goodness. It has just changed the whole game, because I believe a lot of these chronically ill folks who are exposed to mold or Lyme disease long-term, they have ferroptosis going on. So here's the damage. Then we need something called glutathione peroxidase for CoQ10 and BH4 to calm this down, and also vitamin E, which isn't on this chart. So as you can see, this is the 3D chess game, maybe even a little bit more complicated than that, because there's just so many factors that can cause this to occur. Now, let's take a look at just some of the things associated. And I believe we're just hitting the tip of the iceberg. Many of your nervous system, Alzheimer's and Parkinson's, heart failures, osteoporosis, pancreatic issues, kidney issues, gastrointestinal issues, your inflammatory bowel diseases, liver issues, the lung issues, eye issues like macular, are all related to ferroptosis, and I think we're just scratching the surface. This was only first discovered in 2012, so we're talking about just 11 years ago that this was discovered. So from a historical standpoint, relatively new in the medical world. So that's why many people are not talking about it. So now let's look at this map here and look at what creates ferroptosis. Now we have it at a different location in the map, but you're going to see the players are the same. TNFA that we just spoke about, mycotoxins, virus, lipopolysaccharides. And you're absolutely right. I need to put more in here than just HFE, ceruloplasmin, ferroportin. Many other things need to go on here, but anything that'll stimulate TNFA stimulates NF-kappa B. The bilirubin and biliverdin, now here it just says hemoxygenase, but it's actually those things. As we said, calm this down, calm down tumor necrosis factor, calm down NOx. But the NF-kappa B stimulates the NOx. Now there's other things that'll stimulate NOx. There's an enzyme called COMT that helps clear dopamine. And that COMT will stimulate, or the dopamine will stimulate the NOx. We spoke earlier about EMF. EMF affects NOx no matter what, but there are some people who have mutations in calcium voltage channel that allows it to even more so stimulate NOx. One of the things that I'm seeing more and more of is there's an enzyme called SUOX that turns sulfites into sulfates, and sulfates are needed in a detox process called sulfation. These sulfites can often stimulate the NOx enzyme. So we got a lot of things here that make the NOx overactive. So then we make superoxide. There's an enzyme called NQO1 that holds this back. Many people have weakness on their NQO1. Then here we get hydrogen peroxide. And yes, same thing you buy in the store that they put on the cut. And hydrogen peroxide, again, not all bad. It kills pathogens. However, if it's overactive, we have a problem because it'll combine with iron. Now, what we did here, Dr. Rosen, you'll see here we listed all the things. TRF2, ferritin light chain, HFE, transferrin factor, and we're finding SLC40A1 to be significant. We found 4 SNPs that actually cause ferroportin to be overactive, which causes the body to absorb more iron and distribute it more widely. Clinical observation only, when people have homozygous on those ones that are overactive, we oftentimes see more inflammation inside the body. Here's a term probably a lot of people have not heard, thioredoxin, just as powerful as glutathione, that clears hydrogen peroxide, takes care of inflammation inside the cells. Clinical observation only. Weakness on this enzyme. Many times people are very inflamed, and as we've been supporting it, seeing a nice improvement in the inflammation. Catalase is needed to clear hydrogen peroxide. You can have genetic mutations on catalase. Glutathione peroxidase 1 uses glutathione to clear hydrogen peroxide. So you can have a lot that can go wrong here. You can be overproducing the hydrogen peroxide. You can have weakness on catalase, thioredoxin, or glutathione peroxidase that you don't clear it. Then you can overabsorb the iron, hydroxyl radicals. Now, before I get down to the ferroptosis, let's look at glutathione, because glutathione peroxidase 4 is what neutralizes ferroptosis. And we spoke about NRF2 and KEAP1 earlier. They're involved with all the genes that make glutathione. So if you have weakness here, you may not make enough glutathione. So here is that ALOX12. Remember, we talked about arachidonic acid. So if you're not dealing with your fats properly, okay, and you've got TNFA upregulated, here comes your arachidonic acid. And Dr. Rosen, as we're doing these omega quants, we're seeing folks that are actually off the chart on their arachidonic acid. The chart goes to 32, and we're seeing people in their 40s and 50s. Also, cortisol, here's your adrenals. Okay. So the cortisol from the adrenal, so you can see the adrenal gland with acetyl-CoA and progesterone makes the cortisol that calms down this PLA2. So if your adrenals are weak or tuckered out, you're not going to allow the body to stop pulling out that arachidonic acid that creates this ferroptosis. So you can see the adrenals are highly involved with all of this, and their fatigue will add to the problem. So here you make this ferroptosis, and we just spoke about all the problems that can create. Now what we want to do is we want to look at how the body can calm that down. BH4, now I've heard that before. Remember, I talked about that with the nitric oxide. BH4 is needed to make nitric oxide. And as I said earlier, if we run out of BH4 and we're running off BH2, we make superoxide. And people are thinking, well, does that feed back up here? You betcha it does. Another feedback loop. If NOS is overactive from histamine, it'll stimulate it. You can have genetic mutations. Then that NOS2 again will create the RANTES, but we're chewing up our BH4. There's also genetic issues that can cause the body to not make enough BH4. You can have genetic issues, particularly MTHFR 81298. So if NOS2 is upregulated, you don't make enough BH4, and you're making a lot of ferroptosis, you don't have the ability to hold this back. If you've got weakness in NRF2 keep 1 or making of glutathione peroxidase, you don't have the ability to hold it back. Now, I don't have this on a chart, but BH4 is also the cofactor for tryptophan to go into serotonin. What are we seeing a huge increase in? Depression. One of my 4 famous words are, it's not your fault. Because if you don't have enough BH4, you're not going to make serotonin. It's like having a brand new car with no gas. Can't tell you how many people are just relieved that, oh, you mean I'm depressed because I don't have enough BH4? Yeah. What are you seeing with depression, Dr. Rosen?
Yeah, I mean, all mood disorders, right? I think that because with the BH4 and the neurotransmitters and dopamine and adrenaline, you see the overwhelm, the angst, the anxiety, the depression, all of the mood disorders are sort of synonymous with that chronic exhaustion that presents pretty much all the time.
Sure. Now, finally, we're going to talk about CoQ10. So CoQ10, a lot of people are familiar with this, and CoQ10 is in 2 forms. There's a ubiquinone and a ubiquinol. So what has to happen here, and let me get my drawing tool one more time. Here's your ubiquinone, and then we need this enzyme to turn it into ubiquinol, and that's the form that calms down this issue. But it needs, you've heard this before, NADPH. And what knocks down the NADPH? The NOx enzyme. Also, any genetic mutations in here or on NQO1 will further impede the ubiquinone to ubiquinol conversion. And you can have mutations down here as well that will impact your body's ability to make CoQ10. Personally, I've got one huge mutation on this one. So I take 300 to 400 milligrams a day of ubiquinol. If you look at your CoQ10 supplements, if they don't say they're ubiquinol, they're probably ubiquinone. But if you look at the fine print on the back, it'll tell you ubiquinone or ubiquinol. So if you've got any trouble here, or here, or here, or possibly even too much of this, you may need the ubiquinol version of CoQ10. So as you can see, there is just so many ways here that this ferroptosis can go running wild. And I should also point out that ferroptosis is not all bad. If somebody has a tumor, the body will actually use ferroptosis to kill the tumor. So again, I think in the intelligence of the body, this was put there for a purpose to actually kill bad guys. So it's not all bad. If we didn't have ferroptosis, if something bad would happen in the body, we actually need this to kill it. So if somebody's in active cancer, you don't want to take the steps to calm this down. But unless you're there, this can do a lot of damage inside the body. So it's interesting how something can be harmful or actually can be can be life-saving. And from what I understand, there's actually some therapies where they're trying to use magnets and things to pull ferroptosis to tumors and actually temporarily increase ferroptosis to kill the tumor. So that is probably a 2-day lecture in 45 minutes. I'd just like to mention, if anyone's a practitioner, health professional, you may want to consider using our software. I know Dr. Rosen uses it. We have our own genetic test. We have a supplement line. The software that analyzes it, we do the research. This is for practitioners only. We have an online certification course where somebody can actually take the course and learn all of this, again, for practitioners. And there's the website, functionalgenomicanalysis.com. Again, practitioners only, please. If somebody would want to contact us, here's our website and phone number, and here's our support staff for practitioners on the software. So that is a really quick overview of how those two processes, the creation of RANTES, the creation of ferroptosis, can really put stress on the adrenal glands and the entire body.
Yeah, thank you so much for sharing. Isn't it amazing to see your last 10 years in about 45 minutes? And, it's all summed up right in there. Couple of things I will say is that, just as a small plug towards you guys, the staff and the feedback and the way that you get back to everyone is amazing. And as from a practitioner standpoint of view, which I'm looking into more and more now, when you look at the different pathways and you have uploaded the particular nutrients that are evidence-based that support those enzymes, and you have that built into the software such that when you click on the formulation, it gives smart suggestions as to, well, you may not need this because they don't have that particular SNP there. This one is suggested, but because there's so many, we suggest that you boost that level up. And that way you can customize the Bob Miller CoQ10 product specifically for your genes, and it makes it that much more user friendly, and it's a win-win for everyone. Bob, yeah, so a couple questions that I have, which is amazing that that you shared all of that, is I have starred around the words you used as game changer. And just so you know, I hope you don't charge me for the patenting of your phrase, but I say to everyone that I work with before I start with them, there's no bad news. Right? Because when we look at your genes, like you said, you're born with them, you'll die with them, and you can't change them. But the great news is that we can identify where the challenges are so that we can support that function and be able to impact your overall health. So with that being said, when you look at all those pathways, and you mentioned it's a game changer now, in which ways has it been more of a game changer for you now with those two pathways that we talked about, such that there's so many different places to start? How do you know, what's the art of, you have a clinical observation, you have the Bob Miller sneaking suspicions, you want to have, quote unquote, the most bang for your buck. So I guess the question really is how's it been a game changer for you, and how's it changed up some of your approaches depending on how aggressive or how much the patient wants to approach the remedy side of the solution?
Sure. Well, I've been doing this for a long time. In the early days before we had genetics, if someone was inflamed, we'd say, well, let's do some turmeric and boswellia. And, we probably helped some people. We supported the adrenals a little bit. Then as we moved along, we learned about glutathione, and we could see that, maybe glutathione isn't recycling. And then it's like, okay, we've got to recycle your glutathione first. But now with these recent revelations, we can actually see that it may be gain of function on TNFA, or weakness in HMOX, or weakness in SIRT1. So one of the things I like to say is we've got to get away from, oh, this is my protocol, because everyone is unique. So when somebody says, this is what I do for mycotoxins, it's probably helpful, but it's different for everybody. So for one person that's exposed to mycotoxins, you may need to support the heme pathway. For other people, you may need to calm down tumor necrosis factor. For other folks, if it's the NOS, you may need to start first by calming down NOS2 or calming down the NOx enzyme. Or if arachidonic acid is being ripped out of the cell membrane, you may just start there. So you could see, 20 people, say, for example, all being exposed to mycotoxins and inflamed, and you'd have 20 different protocols. So to me, that's the game changer, that you're going in and finding the most relevant place. And then, one of the challenges is many of these people who are inflamed, they'll tell you, oh, I can't take anything. And they'll take one nutrient and they'll open the capsule and take little grains of it and still sometimes have a reaction because they're so inflamed. So, some people you can put the proverbial pedal to the metal and hit lots of things. Others, it's like, well, let's step back here and open this capsule and take grains and see how you do. And everyone is unique. So again, I guess the game-changing part is we don't have protocols. We look at where the weakness is, maybe try to hit the weakest spot first, and then as time goes on, maybe every 5-6 weeks, okay, where can we go next? What can we do? Because I think one of the things that's now becoming apparent in the functional medicine, the naturopathic medicine, the natural health medicine, is that sometimes practitioners get a little too enthused. They see that, oh, you've got mold, you got Clostridia, you've got heavy metals, you've got some virus, we got to kill or clean or something. And many times that backfires. And the person gets worse and just throws their hands up and says, I can't do this. So one of my other favorite expressions is, when the house is on fire, we don't paint the walls and mow the lawn. So many times we have to take baby steps. Calm down that inflammation. Just don't be in a hurry. Don't try to be the hero right out of the gate, because we're hearing more of that people are like, oh yeah, I did a test and you've got Clostridia and I'm going to give you this strong stuff to kill it. And the person's like, I can't do this. It just made me worse. And then that gives functional naturopathic, other kind of care a bad name, because they just made them worse. So another little cliche that I've enjoyed is, I'd rather be a little late than too soon, or the fastest way to get there is to go slow. And so I think as we are being exposed to more and more environmental toxins, it's just unprecedented. And I'll be honest, there's times I worry about, what's this going to do to humanity? Are we going to, are we really going to survive this? Or are we just going to be in a downward spiral here? I'm not saying that's happening. That crosses my mind every once in a while, that, we've done some unintentionally bad things. I mean, when people gave animals growth hormones, they probably meant well of, oh, we're going to get 10 or 12 to 15% more production, never thinking that that's going to jack up the mTOR. When we came out with plastics, oh, we don't have to worry about washing the bottles and all those things, but now the waterway is polluted with all these plastics. All the agricultural chemicals, oh, we can have more food production, we can feed the world. But unintended consequences. And I think, and cell phones, I mean, we all, my goodness, we love our cell phones. I grew up in a world you had to find a phone booth if you wanted to call somebody. So we love it, but we don't know what the long-term consequences are of continual exposure to electromagnetic fields. So we're living in some very challenging times. And you're seeing everyone getting so angry, so polarized. I've never seen a time where people are so angry. One of my favorite stories is when I grew up in a little town called Terry Hill, Pennsylvania. And in elementary school, if somebody would have said, oh, you need to lock the doors and get guards, we would have said, what? Are you crazy? It never crossed anybody's mind, and it never happened. It just didn't happen. So something's going on with our brains, with autism going up, and everyone's coming unglued. And I'm sure you're finding that as well, that people are less tolerant, get angry quickly. They're frustrated. It's a very challenging time to be alive right now.
Yeah, absolutely. Thank you so much for your words of wisdom. I think you can see how far we've come from just MTHFR. I don't think you mentioned it. Well, maybe just in making biopterin, but we've come so far from that. And I think it really is putting your thinking cap on in terms of, well, when people say, well, genetics, what does genetics have to do with it? You're seeing sort of the blueprint of how the environmental factors impacts your body's cellular ability to make energy effectively. And if there are these roadblocks and 3D chess game played underwater, inhibitors, promoters, everything in between, it's really going to make an impact. So I guess you really have to use your doctor's hat in terms of, okay, if we need to go very slow, what is going to have that Pareto principle of the least involvement for the most gain, and slowly building from there. A couple things that I've also, maybe if we can just share, and if it would be okay,
Of
is
course.
some of the successes that you might have had with when you do see that platelet activation and the
Ferroptosis.
Ferroptosis, sorry. Yeah, that you've been using sort of a combination. And again, this is just for informational purposes. You've been using a combination of the CoQ10 at small amounts with royal jelly and potentially hydrogen. I guess it's the hydrogen water. Have you been noticing some really slow but great effects through that, Bob? Or are there
Well,
other combinations of things that you're doing? Yeah.
sometimes they're slow and sometimes they're dramatic. I just had a client that was so excited to tell me, "Oh my God, Bobby, this CoQ10, I'm awake, I have energy." And not everybody experiences that. You just mentioned MTHFR, and I really would be amiss if I didn't address that a little bit. 15 or so years ago, we learned about MTHFR, and most people know that when you've got that genetic mutation, you may not put a methyl group on your folate very well, and that can impact a process called methylation. Really important. I teach about methylation. I actually formulated a product for methylation, but I think we're getting a little too enthused about that for two reasons. One, pregnant women need folate, and the reason they need folate is because there's a process called mTOR that causes the cells to grow. If we didn't have that, we either wouldn't get pregnant, could have a miscarriage, or a deformed baby. So mTOR is very important in pregnancy. But mTOR is also what allows the body to replicate things. It's like a copy machine. And it doesn't care what you put on the copy machine, healthy cell, cancer cell, or even some viruses that we've recently been dealing with. So we got to be careful that we don't overdo that. Plus, in addition, there's an enzyme called histamine methyltransferase that takes histamine, turns it into something called N-methylhistamine, and that has to be cleared further down the road. Methylfolate, methyl B12, and SAMe will stimulate that. So some people, they learn they have MTHFR, and I've seen this happen. I mean, I just recently had a young lady was taking 15 milligrams of methylfolate daily and was incredibly inflamed and sick. And it's like, yeah, no wonder. So if you're not pregnant or you're not specifically working on homocysteine or something else, we've got to be careful with methylfolate. And too many people just, they get a home test and they learn they have MTHFR, they look it up, they start taking a lot of methylfolate, and they don't realize that some of their anxiety and inflammation could be because they're getting too much of it. When I taught classes on methylation, my opening slide was a mother duck with ducklings behind her with the title, "Make sure you have your ducks in a row before you start supporting methylation." So if you've got a histamine problem or a dopamine problem, too much methylfolate could actually be a problem. Now, again, if you've got high homocysteine, if you're pregnant, I mean, there are times we need it, but I believe we've gotten a little carried away with methylfolate. So I put that out there that when you look at the pyramid that I created, the last step is supporting methylation. That I believe we've gotten just a wee bit carried away on that. All well-intentioned, nobody meant anything harmful because everything you heard about methylation is true. But again, back to unintended consequences.
Right.
Can jack up the mTOR, can jack up the histamine, and be more trouble than it's helpful.
Right, and stimulate NOx enzyme as well, right? We already have enough things stimulating NOx. We don't need it stimulated anymore.
Yes.
So just as the other thing I was going to mention is, have you find with these game changers, because the pyramid was really designed for, at the top is methylation, at the bottom are inflammatory stimulators that, and you're looking at it as getting your ducks in a row is another way of saying, well, let's reduce the overhead. Let's reduce the house is on fire. Let's put out the fires before we start mowing the grass and painting the walls. Have you found that pyramid is changing now because of all of the rantes pathways and the ferroptosis pathway in a sense that certain variables now need to be looked at in a 3D motion versus a pyramid kind of way, or is
Well,
that
I think the pyramid still applies because, you know, in the bottom left-hand corner is iron dysregulation, and that's what ferroptosis is.
right?
The NOx enzyme is on the bottom row.
Right.
So, and it still interplays with your ability to make your antioxidants, your glutathione, your catalase. But what I've been finding is that now that we've, you know, increased the function of the maps, that we actually have I mean, I was just showing you static pictures here, but in our software, we actually have interactive maps where you can click on the enzyme, and I didn't use that today because it might be harder to see, but you can actually click on the enzyme and see where it is. But the principle hasn't much changed of knocking down inflammation first, but we've just nuanced it possibly a bit more.
No, it's become a lot more sophisticated. And you've always said, hey, listen, this is a general idea of where to start. But if you see some more specific perfect storm challenges in the middle of the map, then be the clinician and do the appropriate approach. Bob,
Well,
awesome.
you
Awesome.
made a good point. You made a good point. You really do have to be the clinician. You can't have software tell you every move to make. The doctor still has to be or the naturopath, whoever it is, still has to do their job and think it through. No matter what tool you have, it's not going to answer every question for you.
Right. And then also, because I know you do lots of case studies, and a lot of these people are really, really having a hard time. And like we say, when you do a consult, there's no bad news. When you do put these puzzle pieces together and go slowly, Bob, maybe you could tell us a little bit about some of the successes that you're seeing for patients that have been to every doctor and hasn't had any improvements, and how the body infinitely in its intelligence has the ability to heal. Maybe give us some hope to the listeners that they think, oh my goodness, this is just too daunting.
Yeah. Well, firstly, I tell everybody there's no magic cures. You know, there's no take this one pill and in 2 days you'll be better. That doesn't exist. So it's a journey, and it's not for the faint of heart. And it may mean, for some people, we see genetic issues where they may not deal with gluten and they need to stop gluten. For some people, that's a no-brainer. Hey, if that's going to help me feel better, that's good. For other people, you think it was the most traumatic thing you've ever told them, and they can't handle that they can't eat their gluten. For some people, it's less histamine. For some people, it's turn off the Wi-Fi at night. For other people, it's some dietary changes with dairy. And it's we've generally we see when people stick with it for a period of time, have realistic expectations, not miracles, and not, if somebody says, hey, I started on these supplements 3 days ago and I don't feel any better, it's like, yeah, no kidding, right? So it's a journey, and some people are willing to take that journey and some people aren't. And I've learned a long time ago not to argue with people if they don't want to go on the journey.
Right.
But the bottom line is for people who stick with it, the bottom line is less inflammation, more energy, better sleeping, less anxiety, less depressive thoughts. And again, we're not treating any disease because the body's coming into balance on its own. We don't, somebody says, what do you treat with this? We don't treat anything. The body comes back into balance when you create that terrain that's friendly. This goes back to the old naturopathic philosophy of, it's the terrain. Antoine Béchamp said that it's the terrain of the body that allows things to go awry. We've kind of got in the thought that we're going to have a magic pill that's going to suppress the symptom. That did work for a little while, but I think things are now getting more complex because of all the environmental factors, that those days of a magic bullet are going away very quickly. So that's generally what we see: less inflammation, more energy, more mental clarity. But it's not easy. It's not quick. It's not for the faint of heart, So.
Right. But when they're finally getting some answers, especially when they've been told that there's quote unquote nothing wrong, or there's nothing more I can do. Have you found that the Omega Quant has been a game changer as well for you?
Oh yeah, I am stunned how many people will do the Omega Quant and they're off the charts. I mean, they have a charting of where it goes, and it's, like the top I think is 32, and there's people that are 45 to 70. And those are the people that arachidonic acid is being yanked out, and they had no idea that was going on. And, from a disease standpoint, that's not a disease. Arachidonic acid being pulled out of the cell membrane doesn't have a disease name. We're so used to that concept of, I need a disease name. Well, I don't, maybe someday somebody will name it, but to my knowledge, there isn't one. Ferroptosis really isn't a disease to my knowledge. It's a process that occurs. RANTES isn't a disease. It's a molecule going awry. So I think what's happened is, 75 years ago, most of the things we had were bacterial infections, and an antibiotic fixed you up and there you go, or some body part went bad, we cut it out. But we're going on an uncharted territory, again, not because our genetics have changed, but because our environment has changed. I tell my clients this, I said, I'm absolutely convinced. I look at the genetic patterns of autistic kids, and I look at myself, and it's like, uh-oh, if I was a 10-year-old boy, I'd probably be a headbanging autistic mess. So,
Right.
but as this
Yeah.
geezer, I think drawing circles is fun. So, and that's why I think we're seeing such a dramatic increase in these things, because, when I was in my mother's womb, there was no electromagnetic fields. Drank out of glass. I remember as a kid, my parents going to a farmer's market to buy food directly from the farmers. I'd slop around in the creeks and climb the trees. Now the kids are on their computers, pushing buttons, and they're sitting in a school where the food is all processed, and everybody's got cell phones, and they've got iPads, and they've got Wi-Fi in the ceilings. And when I talk to teachers and I say, how long have you been teaching? At least 5 years? And they'll say, yeah, 5 years. I say, what's happened to the kids in the last 5 years? And every one of them says, oh my goodness, they can't focus. They're agitated. They're struggling. And so these kids that were born into this, when in their mother's womb, they were getting high fructose corn syrup and glyphosate and electromagnetic fields and plastics. I believe it's having a detrimental effect to us.
Yeah.
And again, if you've got genetic weakness that wouldn't have mattered 75 to 100 years ago, get exposed to this, these are the potential, the proverbial canary in the mines that are being impacted.
Right. Well, have you found too, just as my theory as well, or that these gene SNPs that got passed down that were evolutionary favorable are because of the environmental inhibitors or the environmental overlappers are now evolutionary not favorable? Does that seem to be
yeah, absolutely. Yeah, there's two theories on how these genetic mutations occurred. One is that during the 1200s, when everyone was promiscuous, and I shouldn't say everyone, when a lot of people were, and STDs were rampant, some of these mutations occurred that just weren't beneficial. But there are beneficial genes. Like, for example, if you talk to people from England or Ireland, many, many times they overabsorb iron. Well, for the Irish, the reason many of them immigrated was because they had potato famines. So during potato famines, if you overabsorbed iron, that was actually to your advantage, and you were more likely to have a healthy pregnancy. So that became a beneficial genetic mutation. So natural selection. In Northern Africa and in other parts of the world, there's an enzyme called G6PD that makes your NADPH. I don't know the mechanism, but supposedly this G6PD mutation protected you from malaria or didn't allow you to get sick from it. So by natural selection, that occurred. When that time, we didn't have as much inflammation, so a little bit less NADPH didn't make any difference. Now, today, since NADPH is being used by NOx and is needed to recycle glutathione, make your nitric oxide, that G6PD deficiency is to your disadvantage. Now, clinical observation only. Bob Miller talking to people. When one parent has the iron overabsorption and the other parent has the G6P deficiency, those children are oftentimes really struggling, or if you were the result of that. So again, when you look at the history of the world, there was never a time that we were as mobile. I mean, you grew up in a country, and that's why they developed their own languages, and we don't know how many thousands of years they were there, and they adapted to their environment. And now we have, travel and everyone's going different directions. So the people that have that G6PD mutation, when they're exposed to things that may use up more of it or there's more need for it, they're in more trouble. When you are when you have that overabsorption of iron, and you might be thinking you're doing a good thing by taking a multiple vitamin with iron, or eating a lot of meat or something like that, it's actually to your disadvantage. So, yeah, it's a complex subject, but that's why. And some genetic mutations are just not helpful at all, and we think those occurred during the 1200s when STDs and actually when people were riddled with sexually transmitted diseases, just damaged some of the genes.
Right. Yeah. Amazing to see, Bob. Thank you so much for your time. I hopefully can keep it open for part 4 when we have new information in a year or so.
We'll be glad to be here.
Yeah, and I appreciate everything that you do and the time and energy you put into helping the world and helping your community and your patient base. Thank you so much for everything you do.
It's been a pleasure, and thank you for the opportunity.
Hey there, I hope you're getting tremendous value out of our videos. If you are, make sure you like our videos, subscribe to our YouTube channel, turn on your alert buttons, and then check out the description below because I have a free masterclass that will teach you how to 10x your energy levels in the next 12 weeks and finally end your energy and exhaustion nightmare.